time constant in the case of the discharging process. So if we want to define, or in order to verify that tau equal to RC, in the previous also video, we said that using the differential equation, when UC equal to A, E minus T over tau, we already verified that A is equals to E, the maximum, and that tau equal to RC. So this was one way in order to verify that tau equal to RC. And another way, we can use the tangent. So we know that tangent alpha is equals to the opposite over the adjacent. So we'll get E over T, but since it's decreasing, so it will be, we'll put E over minus E over tau, minus E over T. The question is to verify that T is equal to tau. But we also know that tangent alpha is equal to the slope of the tangent. So the slope here, it's a decreasing line. So the slope here will be equals to duc over dt, but this is at t equal to 0. And we know that the solution of this equation was of the form uc equals to e minus t over tau, and that the differential equation was of the form duc by dt plus uc over rc equals to 0, which means that if I want to put it at t equals to 0, we'll get that duc by dt. So if this is at t equals to 0, uc is equals to e, which means that duc by dt at t equals to 0 equal minus e over rc. So this means it's minus e over rc. And in another way, if I find here duc by dt, so I will get duc by dt at t equals to 0 is equals to e minus over tau, e minus t over tau. And if I want to find it at t equals to 0, so I'll put here 0. So I'll get minus e over tau, e to the power 0. And this is equals to 1. So minus e over tau. This means that first, I can say, if I look at these three answers, I can say that the intersection between the tangent and the line t is tau itself, using this one and this one. And then using these two, I can say that tau is equals to RC. But if we have this graph, we don't have to verify. We can simply say that in the case of discharging, the intersection between the tangent to the curve at t equals to 0, at t equals to 0, and the line UC equals to 0 is this line here. So this intersection will gives us t equals to tau here. Now, important point to know that at t equals to tau, what do we have? So if I substitute here, I get that at t equal to tau, UC equal e to the power tau over tau, which is equal e to the power e minus 1, and this will give us approximately 0.37 e. This means that at t equals to tau, راح يكون الكاباسيتور صار UC equals صار value 37% من الماكسيموم. So here we have هيدي معناتها 37% من الماكسيموم level. Now at t equal 5 tau, I get that UC equal e to the power e minus 5 tau over tau. واللي هيطلع لنا e to the power minus 5, and this is approximately equals to 0. يعني لما يصير 5 tau, the capacitor will be تقريبا completely discharged. At infinity, if I want to write here, when t tends to infinity, so UC will be equals to e, and e to the power minus infinity, this is 0. So we'll get 0. يعني at the infinity, خلاص صار completely discharged هذا capacitor. Example, if you have this graph and then they ask you to find tau. So here I can say simply that since I don't have a tangent, so I can't use it. So I can say simply that at t equals to tau, we know that UC is equal to 0.37 E. And here E is 20. E equal to UC maximum, so equals to 20 volts, which means that UC equals 0.37 times 20, which will give us approximately 7.4 volts. Now, using the graph, using the figure with the graph, When I put 7.4 on the figure, UC equals 7.4 volts. If I bring it here, then I will say that this is tau implies tau equals 0.06 second.